In this video, we are going to learn about closures in Rust. A closure is an anonymous function. It means a function without a name. For those who already know any other programming language, you might be familiar with this concept. For Java, Python, C# or C++, they are called lambda functions. In JavaScript, it is called an arrow function. For Rust, we call them closures. We learned how to define a function in Rust. We start with the keyword fn to define a function followed by the function name. Then inside parentheses, we declare the parameters with their types. We then have the return type and finally the function body inside curly braces. So if we want to get square of an i32 integer, we can write like fn get square, n as the parameter which is an i32 value will also return an i32 and n multiplied by n as the expression to return the result. Now this anonymous function or closure can be stored in a variable. So instead of fn get square, we can write let get square. Since this is a variable, we can write equal symbol to assign to it. What we are going to assign is the anonymous function. Here we declare the parameters inside vertical bars, also called the pipes symbol. Remaining part can be kept as is, but since we are having a let statement, we'll end it with a semicolon. So we have successfully converted a normal function into a closure. We can further simplify it. Here, we don't need to mention i32. When the closure is actually called for the first time in main, it will lock the type of n with the type of the value sent permanently for the closure, and that type can be multiplied. So it has to be some integer or float. Also, we don't need these curly braces. So this function can be written like this as a closure. Closures are not limited to just one parameter. You can have multiple parameters. Let's say you want a closure to add two numbers. So we can write let add equals a comma b between pipes. These are the input parameters and we return a plus b as the expression. This is how we write a closure with multiple parameters. Now that we can write closures, let's see how we can use it in the program. In the first block, we first declared the closure to get square of a number, and in this print line, we used this get square closure just like a function. Similarly, in the next block, we did the same thing with our add closure. If we run the program, we can see 5 squared prints 25 and 57 printed by adding 12 and 45. For another use case, we can create a closure to get the length of a string. Here we define the type of this parameter s and returns the length of the string. Like before, we can use this closure to get the length of the string Rust. And after running, we can see 4 is printed, which is the number of bytes in the string. You may have a question here that if closures behave just like functions, then what is the need for it? The most critical need for closures in Rust is their ability to capture variables from their surrounding environment. Regular functions cannot do this. They can only work with variables passed explicitly as parameters. In this program, we have two integer variables a and b. We created two functions inside the main function for adding and subtracting two numbers. Since these functions are created inside another function, these are called nested functions. And since they are nested, they can only be used inside this main function. Even though their scope is limited to the scope of this main function, while calling these functions from the print lines, we still need to pass the variable because they can't reach these in-scope variables a and b and has to be passed explicitly as arguments. Whereas if we create closures, we don't need to define any parameter. This will understand that the expression is referring to these in-scope variables. So in the print lines, nothing needs to be passed explicitly as arguments. If we run this program, you can see the output for both nested functions and closures are exactly same. So this is the most critical feature of closures, that it can borrow data from its environment. Few things to remember here. Suppose we have an integer variable for count. We want to create a closure which will increase the count by 1 whenever this closure will get called. Let's print the count every time before it gets incremented. In this line, when the count is incremented means this count variable is getting mutated, so we should be using the mute keyword here. Now again, the change is happening inside the closure. So in this situation, this closure should be mutable as well. So whenever you are changing some value in the closure, both the variable and the closure should be declared mutable using the mute keyword, else you will get error. Now if we call this increment closure, let's call it twice and print the final count outside the closure to verify whether count is mutated or not. If we run this now, you can see this count is mutated by this closure twice and the final value is 2. By default, Rust automatically chooses the least restrictive way. It means that if we have a string variable and printing it inside a closure without changing the value, notice we have not mentioned neither any mute keyword nor any reference to the string. Still, if we run this closure, it will print the immutable reference automatically to print the value. See here, hello is printed. And we can still access the original variable after running the closure. To test this, let's print this name variable after the call to the closure. Now run it again. This first hello is printed inside the closure and the second is printed by this print line. If we want to change the value, then same as before, we need to make both variable and the closure mutable using this mute keyword. And then we can change the value inside the closure. I have appended to the existing string using the pushstr method. Now when we run, we can see this hello is printed before the change inside the closure. And finally, the mutated value by the final print line. It is also possible to transfer the ownership to the closure. To do this, we need to use another keyword at the start of the closure. Before these vertical bars, we need to write the keyword move. So whatever variable is used inside this closure will be moved first, meaning the ownership is transferred first. And then whatever action is required will be performed. So now at this point, if we run this program, you can see we are getting an error. Value moved into closure here. And at this line, value borrowed here after move. If we comment out this print line and run it again, you can see there are no errors. But can we call this closure again? Let's try that. We'll call this closure again here and run. You can see that this closure can be called multiple times without any issue, since now it owns the string value. This final value after update is not printed here. So let's edit this print line for before change, add another print after change, run it again. So when the first time closure is called, before change the string was hello and after change it was hello Rustacean. And during the second call, before change was hello Rustacean and after change again Rustacean is appended to the hello Rustacean. This ownership transfer can also occur without mutation. Let's remove this mute keywords from variable and closure. We need the move keyword as is. Let's comment this change and print statements. Now running this program again runs the closure twice. Under the hood, closures are implementations of 3 traits. Let's look at examples of them. First, the fn trait, which borrows the environment immutably. Here we have created a call with fn function. This f is a generic type and this function accepts a parameter of this f type. Now the condition of the f type is defined here using the where keyword. This means that f is any type that implements the fn trait. So this func parameter becomes a callable object. So we can call it in the function body. Why it is called twice? I'll come back to it in a minute. In the main function, we created a string and then a closure which prints the string. Finally, we are passing the closure as an argument to this call with fn function. Let's run it. We can see the string printed twice. What happens here is when this call with fn function is called at this line, in this function the closure is passed here, which is accepted by this func parameter. So when func is called here, this closure gets executed. Hence, the string gets printed. Now, three things to note here. First, since func is called twice, so string also printed twice. Second, in this call with fn function, we never passed this string variable. We only passed the closure. But since closures can reach the environment where it is defined, it is able to get the value of the string variable. And third, this closure is not changing the string, and it is called here as an implementation of the fn trait. So the string value is referred immutably. Hence, we can call the closure multiple times without any issue. It is worth noting that all types implementing fn trait also automatically implement the other two traits, FnMut and FnOnce. So when this func is called, Rust looks at the trait hierarchy. Starting with fn trait, since our closure doesn't modify anything, it qualifies for the most flexible trait, which is fn. That is exactly why calling it twice works flawlessly. Now I have modified the same example. This time, a call with FnMut function with generic f is created and with the same parameter func. But this time we are making this parameter mutable because this f generic type should implement the FnMut trait and called this func twice in the function. Moving on the main function, we have a mutable integer variable called counter, and this closure increments the counter every time it is called. Again, here we called this call with FnMut function passing the closure as an argument. The difference here is that since this closure modifies the counter, so it implements the FnMut trait. If we run this program, it prints counter 1 and counter 2 since we called the closure only twice. One thing you might ask here, that previously when we saw this mutable example, I said both the variable and the closure should be mutable. But here, without the mute keyword, how can it run fine? The difference from the previous example is that here we are not calling the increment closure from inside the main function. Instead, at this line, we are passing the closure as a value to another function. So ownership of this closure moves from main into that function, and this function accepts it as a mutable closure. That's why it worked fine. To test whatever I said, if I comment this function call and directly call the increment closure once, you can see we are getting error. Cannot borrow increment as mutable as it is not declared as mutable. Now if we make increment mutable and run, it prints the counter. Let's uncomment this function call again and keep this increment call as well. Let's see what happens when we run it. We get error, value borrowed here after move, because this function have the ownership. So after that, we cannot call increment anymore. Now this example is with FnOnce. Same function created, but this time it accepts types that implements the FnOnce trait. Main function, similar stuff. We created a string, printed inside the closure, and passed the closure as an argument. Let's run it, and it also prints fine. The change here is that we called func only once, because it can be called only once. After executing this func, the closure gets consumed and destroyed. So if we try to call it again, we'll get error because of using something that is already moved. So these are the three traits implemented by the closure. Closures have anonymous types. So if we want to return closures from a function, we can use it like this. At the return type of this function, we are implementing a function that accepts two i32 values as parameters and returns an i32 value. Basically, this function returns the remainder. So in main, we can just call the function to get the closure and use it. It will work fine. The best use of closures are with iterables. A suitable example can be iterating through a vector. Suppose we have this vector with some single digit integers. We can sort it by using the sort by method and pass a closure for ordering of the number in ascending order. We can use map to transform every item in the vector using iterable sequence. We can also filter out the even numbers from the vector, and fold can be used to reduce the items into a running total. All these, among with many others, can be achieved using closure. Closure simplifies programming a lot by making code less verbose. So in this video, we have learned what closures are, why Rust needs them, how closures capture variables, the 3 traits implemented by closures, the move keyword, passing and returning closures, and closures with iterators and algorithms. If you have any questions, do write them in the comments. And don't forget to like and subscribe. I'll see you in the next video with a new topic. Till then, happy coding.